Hi, and welcome to Periergy. Today, we're going to be looking at some exercises for the if statements, which I have explained in the last video in C++ course 04. Remember that this is a C++ course, and if you don't exercise, you're going to have a lot of problems in the future, and it's basically and generally important to do a lot of exercises on all the things that you learn with this course. And therefore, today we're going to look at 10 different exercises. I suggest you to do more, even more, but I don't want to overdo this course with a lot of exercises. You can do that by yourself. And therefore, these are the exercises. These are the first 6. You can pause the video and just look at them. And we're going to go through them individually, one at a time. This is the 7th and the 8th, the 9th, and then we have the 10th one, which is a final exercise that is going to be the most difficult one. Please try to do the exercises before I show you the solution. So try to do them by yourself, follow along, and finish them before I show you the solution. This way, these exercises are actually going to give you some help. And we can start with the first exercise, which states write a program to accept two integers and check whether they are equal or not. This is example of an input, and this is an example of an output. Now, the first thing that we want to do is think. And the question is, what are our variables? We have a program that has to take two integers and they have to be whether equal or not. Therefore, I would say we would need 2 to 3 variables. Those 2 to 3 variables could be one variable and the second one for the two integers. And maybe we could use a variable for the result of their equality or their disequality. But we don't need the third one. But let's try with an additional variable. I'm going to show you both the codes. So we have our first input. It's going to be an integer. Therefore, I can write int, and we can say first number, for example. And we're not going to give it a value just yet, and therefore, and then we can create our second number. The thing that we're going to check for is if they're equal or not. Therefore, if we want to use another variable, we're going to need a bool. And this is going to be the result of the equality. Now, to input, for now, we're just going to assign values to these variables, but in the future, I'm going to show you how to actually take input from the console, from the terminal. For now, let's just try the input that these guys gave us, because these exercises, I found them on the internet. And we can say first number assigned 2, and second number assigned the value 3. Now, the result of the equality is going to be what operation is going to be first number equal, but with a double equal sign. Otherwise, this would be an assignment operator. Second number. And then we can plug this into an if statement. The output should be, and check whether they're equal or not. Okay, this must be a mistake. It should be not equal. Right, sorry for the mistake. Therefore, if we put a result in here, if the result is true, because this is basically saying if the result is equal to true, all right, but we can just say result, then I want you to say the first number and the second one were equal. Otherwise, and our way to say otherwise, I'm going to remember, is else, otherwise. I want you to say the input numbers were not equal. If we run this code, we can see that we can anticipate the result. 2 is not equal with 3, therefore we're going to see the input numbers were not equal. At least we should see that result, and we do. If we tweak the values, 3 is equal to 3, and therefore the first number and the second one were equal. Now I forgot a 1 in here. And this is our first exercise. This is the solution for the code, but there are many ways to solve it. Like there's no actual need to use a third variable. Therefore, we could just say like erase this line and just say if this first number and second number are equal. Or another way to do this is instead of saying, let me just, all right, one. Instead of saying if the result is true, we could say if the result is not true. And the way to do that is just put an exclamation point in front of the result. This is going to be saying if the result is equal to false, if I just put the exclamation point. And we could move this right here and move this other one right here. It's going to do the same thing. Now we have them equal, and therefore you should say the first number and the second number were equal. And that's what it says. Our second exercise says, write a program to check whether a given number is even or odd. All right, now what are our variables? We have just a number, and we have to check if it's even or odd. This time I'm not going to have a bool for the result, so the only thing that we're going to have is one variable. It's going to be an integer 1, because there's no way to say that a floating point number is actually even or odd. These definitions only go with integer numbers. Therefore, we can have our number, an integer 1, and inside here, I'm going to give it the value. Don't know what value yet. We're going to try with 8 just a bit later, and the result should be even. Now, how do I check if a given number is even or odd? Well, the way to do that is divide the number by 2 and look at the remainder. If you divide the number by 2, the remainder of that operation, if the given number is even, should be 0. Otherwise, 7 divided by 2 is going to give a result of 1. So is always going to give a result of 1. It is going to be 0. Therefore, we can just check the modulus operation, the remainder operation, and that is our number, percentage sign, 2. If that result is 0, the number is going to be even. Otherwise, it's going to be odd. To do that, we can say if number modulus 2 is equal to 0, then I want you, oh my God, what did I do? I want you to say, cout the number is even. Otherwise, else, cout the number is odd. All right, let's check our codes. Now I forgot some semicolons and I forgot to give it a value. Let's try with 8. That was our input, 8. And it should be saying the number is even. If you press F9, the number is even. Now let's try with 7, should be odd. The number is odd. Now, there is some other case, which is what happens if the number is negative? Do we check for that? What happens? -8 actually does give a result, a remainder of 0, so it could be considered even. But what if we plug in 0? What happens? What is the remainder of 0 divided by 2? Is 0, and therefore we could say that 0 is even though not everyone on the planet actually says that 0 is even. A lot of people just say that 0 is nor equal, nor even, nor neither even nor odd. That's the way to say it, I think. By the way, this is the way to check if a number is even or odd. This was the solution. If you did it differently, it doesn't matter. There are infinite solutions to this shit, to this stuff. I'm sorry for the bad word. And therefore, don't worry if you did it differently. And then we have our third exercise. Write a program to check whether a given number is positive or negative. Example 8, 8 is positive. Now, this is even easier. We can try and just say, we can leave the same number, but the if statement is going to change. Now, what happens if a number is over than 0? That must mean that the number is positive. And therefore, we can just say, cout, the number is positive, and line. But else, if the number is lower than 0, then that must mean that the number, the number is negative. There's another case, and that's the case in which the number is actually 0, which is our case for now. And we can just say the number is 0. The number is 0. Now, if we didn't put this case, because we didn't include, this is not a greater or equal or less than or equal. This is just greater and less than. And that means that if we left the code like that, with just an else if, we would have not seen anything because our result was 0. So if I erase this, I can just do that really quickly. F9, no result. But if I put it back, the edge case, this is called the edge case because it's a really particular case that we didn't consider before, is going to be treated. And therefore is going to say the number is 0. And this is if you want to consider the number 0 not positive and nor negative. But if you want to consider it positive, you can just put an equal sign there and remove this edge case and just do that. And therefore it's going to say the number is positive. But let's check if it actually works. Let's plug in an 8, the number is positive. -8, the number should be negative. And there we are. Next off, we have write a program to find whether a given year is a leap year or not. Input 2020, output leap year. Now, we have to think about it. When is a leap year? When is a year a leap year? That is when the year is actually the remainder of the division of the year by 4, therefore 2020 divided by 4 gives a result, a remainder of 0. Therefore, if it's divisible, I don't know if that word actually exists, but if the leap year is divisible by 4, that means that the year is actually leap, and therefore we're going to have a 29th of February. Now, our variables are going to be just a year. We cannot have a floating point here, therefore just a year. It's going to be an integer 1, year. We're going to give it a value right here, for example, 2020. And there we're going to check, all right, is our year divisible by 4? And that means, does it give a rest of 0, the modulus operation? If the answer is yes, then this is a leap year. Otherwise, we can just copy this line and say else. This is not a leap year. Now, is 2020 a leap year? It is. This is a leap year. But 2021, sorry, which is the year we're currently in, is not. This is not a leap year. This is my solution to the exercise. Next exercise is write a program to read the age of a candidate and determine whether it is eligible for casting his or her own vote. All right, example 17, not eligible. In Italy, you cannot vote if you're under the age of 18. And I live in Italy, so I'm going to apply that rule. I don't know in your country how it works. Now, the only variable that we're going to have is age, but maybe we could include a minimum age to vote. This is a really long name. Maybe I could just say minimum age. And in Italy, this is 18. We can just give a value of 17, and there we're going to check, all right, is the age less than the minimum age? It's going to be actually less or equal than the minimum age. Well, that means that, or just less, not equal. That means that you're not eligible to vote. All right, see out, you ain't eligible to vote. I know that's slang. Yeah, I know, I'm a gangster. I'm not, I'm just stupid. See out, you are eligible to vote. All right, that's a difficult word. All right, let's go through it again. Now, if your age is less than the minimum age, that means that you cannot vote. You cannot cast your vote. Otherwise, if you're 18 or 19 or whatever number after that, I mean, there's a certain limit, which I guess is the average life of a man in Italy, maybe, which is probably doesn't go over 100 years. But if you're over 18 and this program accepts every number over 18, even a million years, well, then you are eligible to vote. And if we tried it out, you can see that you ain't eligible to vote because I am 17, and I really am 17. But once I get to my birthday, I'm going to be 18, and I will be eligible to actually vote. Our sixth program says write a program to find the largest of three numbers. Now, this is maybe the most complicated one that we've done so far. These weren't that difficult. But now we have three variables, 2, 8, 4, and we're going to look for the greatest number of the three. Now, how do we do that? Let's create our variables. We have a first number, a second number, and a third number. They could be even double because this should work the same. Therefore, let's just put them double. Yeah, it's going to be cooler, yes. Now, we can give and assign values to them right here. What were the values? 2, 8, 4. Yeah, let's say the first number is 2, the second number is 8, and the third number is 4. Now, when and how is a number greater than the other two? Well, let's try the way I said it. A number has to be greater than the other two. Therefore, if I say let's say the greatest number, was first number, then first number will have to be greater than second number. Let's say even equal, because it doesn't matter. If this was like 8, it doesn't matter which one is the greatest. They both are. It has to be greater or equal to second number, but at the same time, therefore, and logic operator, the first number has to be also greater or equal to the third number. And this is the case in which the greatest number is the first one. And we can just say the number, which is actually as simple as writing this and then end it with a semicolon right there. But if instead of having this, we had the second number do the same thing, therefore, let me change some things. What did I do? Okay, let's go through this. If the second number was greater than or equal to the first number and at the same time greater than or equal to the third number, then the second number would be the greatest one. And therefore we would have the greatest number is actually the second one. Colon, space, second number, outline, semicolon. That's a colon, not a semicolon. And then we have the last case in which none of this actually happened. And that means that the actually greatest number must be the third one, because if it wasn't the first one and it wasn't the second one, the greatest must be the third one. And even if they were equal, like 8, 8, and 8, the first if, because it would be evaluated to true, first number would be greater or equal than second number because they are actually equal. Same thing for the second condition. This would be the thing that you will read in the console. Therefore, all the cases were taken, were evaluated and looked for. The last one is the case in which the third number is actually the greatest one. And in that case, we can just say the greatest number is the third one. And we can say third number. Now, if we try this out, the output should be the greatest number is the second one, second number, because we had an 8. 2, 8, 4, it should have been the second one. If you press F9, you can see that the greatest number is the second one, 8. Now let's try to have the first number to be the greatest one. It is 16. All right, what if the third number was? It is 20. Okay, what if they're equal? Which you see that the first number is the greatest number. Now, this might be not that accurate, because if they're equal, is actually for the first number greater than the other ones? So is it the greatest number? You could change the statement like just saying first number like this. Yeah, that would be the same thing, because the program is actually asking for the greatest number. And even though you're not saying that you're actually printing the first number, you would see just 20. Because this condition would be the first one of the conditions to be true, and therefore this is the line of code that is going to be compiled and run by the compiler, and everything else is going to be ignored. All right, this was my solution for this exercise. All right, time to do the seventh one. Write a program to accept a coordinate point in an XY coordinate system and determine in which quadrant the coordinate point lies. Input 8, -3, and the output is the fourth quadrant. Is it? Yeah, it is. It is right. Now, if you don't remember math class, I'm gonna basically just say what that means. Now, the coordinate system is divided in four quadrants by two axes, which are called the x-axis and the y-axis. If you just imagine them, because I'm drawing them with my cursor, and I don't have any other way for now. And by this definition, this would be the first quadrant, this would be the second one, third one, and fourth one. Now, because these axes are orientated, they have an orientation. That's the thing that I want to say. And the x-axis is positive this way to the right, and the intersection is called the origin. Therefore, if you go left, the numbers are negative. So if you go negative, if you go right, the numbers are positive. Same thing with the y-axis. It is orientated upwards. Therefore, positive number, negative numbers. The way to give a point coordinates is just give it an x value, therefore a position in the x-axis, and then a position in the y-axis. And because of the fact that these axes are positive this side, negative this side, positive this side, negative this side, the different signs of the numbers of the coordinates tell you if where the point is in what quadrant. Now, a point in the first quadrant has a positive x and a positive y. A point in the second quadrant has a negative x and a positive y. Third, negative x, negative y. The fourth as a positive x and a negative y. Why is that? I'm sorry for the pun. Now, if the x is positive, we are here in this part of the screen. And if the y is positive, we are here in this part of the screen. And this was the actual first quadrant. If the x is negative, we are in this part of the screen, this too. But if the y is positive, we are right here. Same thing, if the y is negative, right here. X positive, y negative. All right, therefore, for our point, we're going to have an x value and a y value. We're going to give them values. For the x was 8. And for the y, we had a value of -3 for now. And we said, okay, what is the condition for a point to be in the first quadrant? The condition is the x value has to be over 0, or actually, well, no, I'm not going to put that. And, or maybe I could put that. I don't know. Let me just put it. We're not going to see the condition of which we are going to have the origin point, but whatever. The y value has to be also positive, therefore greater than 0. And then we are in the first quadrant. If that's not the case, else if, and we can copy the condition and tweak the values and the operations. If the x value, I forgot an equal sign. To be in the second quadrant, the x value has to be negative and the y value has to be positive. And therefore we have the second quadrant. Second quadrant. Let me remove the white space because I hate it. Else, if to be in the third quadrant, we need a negative value with x and a negative value with the y. Therefore, this is the third quadrant. Third, I want that capital. Third, I said I want that capital. Third quadrant. And last case, we're going to be in the fourth quadrant. Therefore, I can just say fourth quadrant without putting the condition because I am sure because the way you wrote it is going to leave just one case ahead, behind, not ahead, behind. That case is going to be the case in which the values are positive x and negative y, and that's the fourth quadrant. Let's end the line. Now this should say fourth quadrant, and it actually does. What happens if I had something like this? This would be a point in the third quadrant, and it is. Now, what if this is positive? We have a point in the second quadrant. That's right. If they're both positive, there should be a point in the first quadrant. Now, what happens if we have the origin? The origin cannot be considered like, maybe it could be considered a point of each quadrant. Therefore, we could actually say at the first if, we could say if x value is equal to 0 and y value is equal to 0, then that means we have the origin. Or maybe we can just remove all the equal sign. Let me do that really, really quickly. And after doing that, we have to give a condition to the fourth one. Therefore, I could say if x value is, it's kind of like this, but this has to be greater than 0. The last case would be that we have the actual origin. And I think you can get why, even though my explanation wasn't that great. Yes, I'm well aware of that. Oring. Yes, oring. What did I want to say? Origin. Yes. And this is the actual origin. And if I had something like this, it would say origin. Why? Because I removed this. But if I set that, that would be origin again. Why? Because I removed the equal sign, and now it would say first quadrant. The thing is, you cannot actually do that like this. You have to do something like put in another if right here and say the condition of x value is equal to 0 and y value is equal to 0. Then you have the origin. Otherwise, it's not a point, which is the intersection of the two axes. And you could do that like this. You could leave the things like that, or you could just remove them. And to be actually super accurate, you could say if x value, what did I do? I don't know, is equal to 0 and y value is equal to 0, then we will have the origin. And this is to be really, but really accurate. Otherwise, else, bloop. And all of this code is going to be inside the else, so I can just indent this. And I need to include this again. I'm sorry, otherwise it's not going to work, I think. On the top of my tongue, I have the answer. That's the way. All right, and that should say first quadrant exactly. But if I had a 0 right here, it's going to say origin. It didn't, because I didn't put a second equal sign, so it was trying to assign the value 0 to the x value. Now it should work. Origin. All right, that was really complicated because I made it so because I wanted to be super accurate, and I wanted to show you the different kind of ways of solving this exercise in the different kinds of accuracy that you can apply. And this is the most accurate one, I think. Maybe I'm wrong, but I shouldn't be. Next one. Are you following along? Write a program to read any day number in integer and display day name in word. This is really easy. Now we have, what did it say? Any day number in integer. All right, we have our day in integer. And the example is 5. So let's say 5. And now we have to build our chain of if and else ifs. Now, if, let me copy this so I don't have to rewrite that every time. If this is 1, what day is it? All right, that's too much space. I don't like it. Let's do this. It's Monday. Not Monday, it's a Monday. Yeah. And line. Yeah, Monday is not the greatest day of all time, is it? If it's 1, it's Tuesday. Yeah, a little bit better, but still the start of the week. Yeah, not that great. Tuesday. And line. Next up, we have Wednesday, the unpronounceable day, because I have no idea how to pronounce it. Yes. Wednesday. No, for real. Like, do you pronounce the N? Like, when the, I have no idea. Wednesday. When, I think Wednesday. Is this right? I don't know. Well, I have a squiggly line, so this must mean that it's not right. Wednesday. Oh, Wednesday. What the hell? You guys are crazy. Why do you speak Italian? Like, what the hell? Wednesday. How do you pronounce this? Wednesday. It's horrible. Petition to change the name of Wednesday into Wednesday without D, or somebody tell me please that you don't have to pronounce it, the D. All right, then we have Thursday. Thursday. Okay, I cannot put capital letters today. That's fine. I can just correct myself. And then we have our actual case, finally, day 5, and that's Friday. Maybe the best day because you just finished school. I'm in school, so best day for me. Or maybe Saturday is the best day. Yeah, that could be the best day. Else if day int is equal to 6. Yeah, this is the best day. You can party. Saturday. Oh, wait. Capital Saturday. Could I be more stupid? I'm not going to write that again because I'm tired. Well, I have to. Yes, because I don't. If you input a day which is greater than 7, we only have 7 days in our week, it's going to say Sunday, and we don't want that. We want this instead. We want to add a default case. Now it's going to be Sunday. Oh my God, can I just put one capital letter? Just one, for real, one. Else, what is the else case? The else case is that is not a day. All right, this is the solution. That's a Friday. Yeah, that was a long code to write. Boring, but I suggest this is a really cool exercise. Monday, there's no need to try them all. The only thing that you have to make sure that these are all double equal signs. That's important. All right, next up we have write a program to read any digit and display the corresponding word. Yes, 8 becomes 8. All right, I can just use this digit and just replace everything like this. And just modify a little bit my couts, my prints. And of course I have to add a little more of those. So I can just copy all of this and just print it and then print it again and maybe again because it's going to be 8, it's going to be 9, it's going to be 0. So we have 1 and then we have 2. What's your favorite digit, guys? Yeah, this is my way of making conversation. Yeah, this is the way to entertain. What is this? 6. I've just realized that maybe I don't know how to write 8. What happened? All right, so yeah, that's right. Yeah, that's right. Yeah. 9 and then 0. This was really easy. If you didn't do this, yeah, maybe you should watch the video again. Yeah, because this is fairly easy. Now let's see if this works. It should. Okay, let's do what happens if I plug in 10. I didn't put an else right here because I should say that ain't a digit. And 10 is not a digit, of course. Don't know the definition of a digit. What is happening? I don't know. It's taking really long. All right, well, the code works, of course. August, I already have one open. I am sorry. The code, of course, works. Now, the only thing that I would suggest to be really careful of is double equal signs. Double, otherwise you're going to assign a value to the digit. This is going to be assigning the value of 1 to digit. You don't want to do that, of course. And now we have the final exercise, the most difficult one. Yeah. Clap to yourself if you made it this far without looking at the solutions. You're a really nice programmer. No, you're not. You're really not. This is too early to say that, but Props to you. Write a calculator that asks the user for an operation, then it asks for the numbers, and then it evaluates the result and prints it on the console. Now, what do we need? Operation, numbers, evaluation. We have the operation that could be addition, or maybe you can just say plus. Therefore, we need maybe a string that could hold the operation, and then we need, let's say, just two numbers, maybe two doubles. Let's call it A and B, just to be quicker. And then a result, a way to keep track of the result. That could be a double as well. What did I write? That result. The first thing to do is ask for an operation. So you could say, what is the operation? The operation. And now is the time to actually show you how to take an input from the console. The way to do that is use something really similar to cout. Now, if you remember, cout stands for console output. Therefore, to take input from the console, yeah, you guessed it, console input, cin. But then you have to use the reverse, the opposite of the angle bracket, which is the greater than sign, a double one. And that's what it's going to do is actually take the input from the console and put it inside a variable. Now, which variable? We need an operation. Therefore, it's going to export the operation. It's going to say the operation, put it inside there, and then we're going to have a value for that. So if we cout that, we would see that. But the first, let me just remove my antivirus for now. Otherwise, it's going to give a little problem. Now, if we try this out, it should say, what is the operation? If you press F9, the console should create, what is the operation? And let me say addition. And you can see that in the line after that, it actually said addition. So the value, the thing that I wanted to give to the variable was actually stored inside the variable. I prefer to do that like this. All right, if my operation is an addition, operation is addition, we're going to have a string, therefore we're going to compare it to a string. We have addition, or let's say you can also say operation is equal to the plus sign. Now, I know this is a single character, but because we use strings, we have to put the double quotes. Yeah, we have to put the plus sign inside the double quotes. Else, if operation was subtraction, that's a difficult word, or operation was a negative sign, or hyphen, should be called hyphen. Am I wrong? Correct me if I'm wrong. Else if operation is equal to multiplication, or operation is equal to asterisk, not like that, but like this. Whoa. And second to last one, we have division, which I'm just gonna copy because I'm tired of retyping everything again. Division. Forward slash. Same thing for the last one. What am I going to do is else if operation is, let's call it modulus. I don't know if it's called modulus or remainder. I don't really know, but this is the sign. All right, if we have an addition, what we want to do, well, actually, we could do that here. We could ask for the numbers on which, what numbers you want to do. the operation on. And we could say cout first number. We're going to let the user put that inside our A. And then we're going to say just end the line, just to give a nice little spacing. Then the second number is going to be inside B. And we're going to give a little spacing again. If the result is an addition, if the operation is an addition, well, then result is going to be A plus B. And we can just say result. Well, actually, this line is going to be equal for every operation. Therefore, we could just say this right here. Cout result. I'm sorry, I am so dumb. This way, no matter what operation the user chooses, everything is going to be evaluated inside these lines, and then it's going to be written inside here. Now, if the operation is a subtraction, we're going to have something like this, A minus B. Really simple. If I could type, multiplication is result A times B. And then division is a little bit weirder because we have to say that B is different than 0. Because you cannot divide by 0. If B is not 0, then you can do the operation. Like you can say result is equal to A divided by B. But if it wasn't, if B was 0, this would say just nothing. This result tends to infinite, but it's not equal to infinite. Same thing for this. B has to be not 0, otherwise we're not gonna ever have a rest, but this is a modulus operation. All right, so run the code, try it out. Why is it giving an error? All right, let me show you this. So if it's giving you a mistake, an error, you can just go inside view, then say, what is it? I don't remember. How's it called? I don't know. Go to view perspective and then default, and you should see the build log. And it says, no, build messages. It says invalid operands of types double and double to binary. Of course, because you cannot have a modulus operation between doubles. So we need to use different types. Yeah, let's just say int. Now let's change back to the grade and only grade minimal view, and this should work. Yeah, if you want to use the modules, you cannot use other than that. Now, what is the operation? Let's say addition. What are the numbers that you want to do the operation on? What were they? 8 and 6. 8, 6. The result is 14. You can try this again, not in the Word document, but here. And let's say we want to divide or add the modulus. No, that's not an operation. We want the modulus between 9 and 2. The result should be 1. And that's the result. You can play with this code a little bit, and maybe you can find your own way to actually be able to use doubles and at the same time use modules, because if you go into the modules operation, you would need to use different variables. You cannot use doubles. You have to use integers. You can do that by yourself. I'm going to leave this exercise without a solution. Or if you want that, you can just write me on the email, me.periergy@gmail.com, or leave a comment and just tell me, and I will show you the solution. Thank you for watching. I hope to see you in the next video.